Thumbs up. Okay. All right. Well, we'll get going, and I can add a few people as we go along. So today, the purpose of our workshop today is to talk about fall seeded cover crops. What we're largely going to be talking about, I'm going to do a bit of an overview of just the benefits of fall cover crops, and some of this is, some of this may be very common sense. Some of it may be stuff you're hearing for the first time. A lot of it's drawn on improvements and research from other places, as well as here in Prince Edward Island. Then we're going to delve a little bit into two research projects that we've been doing as part of the Living Labs initiative. So the first one is cover crops ahead of potatoes, and I'm going to talk about that. The second one is cover crops after potatoes, so after potato harvest. Morgan's going to largely talk about that. And then I'm going to end off on a little bit of work, just updating you on some work we've been doing on fall hilling ahead of potatoes. And we have a little more data to share there. And then at the very end, we're going to talk a little bit about just biosecurity, just because that's a timely topic for PEI growers. So let's talk about the benefits of fall cover crops. Of course, one of the very first things I think that everybody would acknowledge that's a benefit is for erosion control. So it's been estimated that about 80% of soil erosion happens during heavy rainfall events in the spring and the fall. According to SARE, quick-growing cover crops can hold soil in place, reduce crusting, and protect against erosion due to wind and rain. That all sounds very common sense, and I think we all know it's important to try and prevent erosion. I guess the one thing I would point out or reinforce is that topsoil is a finite resource. It takes an awful long time to grow topsoil back and a very short amount of time to lose it. So not only is it, we want to keep soil in the fields for productivity purposes, but also keeping the neighbors happy, avoiding that blowing snow with dirt in it, and avoiding those erosion gullies that sometimes we see in the fall, the spring, and help and keeping everybody happy, including yourself. Just a couple of photos of some gully erosion that I saw last year when we were out soil sampling. Neither of these fields were very heavily sloped or very highly sloped. The field on the left kind of had a gradual slope to one corner. The field on the right, again, a bit of a gradual slope, a bit of a knoll, but not, definitely not a very, a big gradation. And you can see, with very little, with no living roots and no root mass at all, and just a little bit of residue on the top, you still can get quite a bit of erosion. And those eroded parts of the field will generally be less productive. We've seen in some previous work that those eroded spots, even if you get them leveled and filled in, they've got less topsoil, they've got fewer nutrients, they've got less organic matter, they're more likely to heat up in the summer, and they have lower yield potential. So we need to try and avoid having those eroded spots. Of course, movement of soil to water courses, we want to avoid that. We want to avoid siltation of water courses, anything involved with fish kills, that's all stuff we want to avoid where it's all possible. I read a quote the other day, it can take up to 500 years to build an inch of topsoil. So we need to keep what we have, and that's never been more true. Another benefit that can come with fall cover crops is preventing nitrate leaching. So nitrates are usually at their greatest risk of leaching in the fall. They can leach in the spring as well, but PEI soils, due to their sandy nature and the high rainfall we get here, are highly leachable. So not only are you losing nitrate from your soils that could be helping to feed future crops, but you're also potentially losing nitrate to the environment, where nitrates can load. They can cause anoxic conditions in the rivers due to overgrowth of sea lettuce and seaweed. They can contaminate groundwater, all those sorts of things. So we want to avoid that leaching. Where nitrate, of course, comes in many forms. So there's leftover fertilizer, like if we have a dry year like this year where some of the fertilizer doesn't get broken down, doesn't get utilized, you're going to have the leftover nitrogen there. You've got the natural release from organic matter that happens every year, the breakdown of crop residues that that either in the worked into the soil or on top of the soil. And if you apply any manure in the summer or the fall, that's also going to break down and release nitrate. So having a crop that can hold and capture some of and utilize some of that nitrogen is very valuable. And I think I said most of that. Keeping something growing. There's a lot of growing, there's a lot of building information, building literature from soil health researchers that are showing that a growing crop, a green crop, not only holds the soil together and takes up nutrients, but it also builds the soil organic matter, improves aggregate stability, which is the structure of the soil, increases microbial activity and nutrient cycles, and just overall improves soil health. So the maximum amount of time that we can have something growing, the better it is going to be for the health of your soil and for feeding future crops. Fall cover crops can also help with weed control. So a dense cover crop can outcompete perennial or winter annual weed species that would come up in the fall. Some species are alleliopathic, which is a fancy word for saying that they directly inhibit weeds through their, just by growing. So like by, these species growing usually produces a root exudate or something that retards the growth of other weed species or other species. So things like fall rye and buckwheat have really been shown to be quite strongly alleliopathic. Oats maybe to a little lesser degree, but can find that in the literature a little bit. Managing soil moisture with fall cover crops. So a fall cover crop, again, it can help with water infiltration, creates more stable soil aggregates, and there's more room for for water to be held in the soil. Having a cover crop surviving to the spring, so something like winter wheat or winter rye, can help dry out and warm up a field that would naturally be a bit wet or heavy. So a couple years ago, we had an agronomist here from North Dakota, Lee Breeze, and he was talking about they use fall rye in North Dakota on a lot of their heavy ground to just get it dried out fast enough so that they can plant into it. So that's that's an option for naturally heavier parts of your field or heavy fields, that sort of thing. And then of course cover crop residue will generally catch more snow over the winter, so that's good for preventing wind erosion, but it's also good for allowing more localized snow to settle in that area. That's more water, more moisture to recharge that soil for the next year. Just a photo, courtesy of Peter Webb and Tyler at the department helped me track some photos down. But just that living cover or that extra trash catches a little bit more snow. A lot of us will have seen say fields side by side, one that's got a cover crop and one that's bare, and that bare land doesn't catch nearly as much snow and is more prone to wind erosion. We can also use fall cover crops to fight pests and diseases. So a lot of you would be familiar with using mustard or buckwheat to fight wireworm. We're still sort of sorting out the effect of verticillium and nematodes with different fall covers, but early indications from some of our work is that the grass and the brassica mixes don't really increase numbers too badly, particularly for vert. Nematodes, we're probably still figuring that out a little bit, but it doesn't look like they're a massive issue. And we still may have a bit of work to go in terms of fully delineating that. Brassicas, and so by brassicas, I'm talking about, mustards and radish and kale and, winter canola, all those types of crops. Generally, they're not a host for a lot of fungal diseases, and they make a nice break crop in a rotation. Particularly if you have, a grain crop and a potato crop, brassicas are a nice break to break some of those cycles in those fields. Fall cover crops provide a good opportunity for applying amendments like manure and compost and lime. So you can, if you want to apply manure before tillage and then plant a cover crop to help capture and hold those nutrients, that's an option that many people are doing. You could apply compost or manure on the cover crop, for the same reason. So it's going to help use some of those nutrients right away. It's also going to protect that manure a bit from erosion, because you've got a crop that's going on to that's going to, just specifically from wind and water erosion. It's going to protect that manure, and you're not going to lose it as much. And you're able to put the manure on something without having to do tillage. So if you can save a tillage pass, that's an option as well. And that cover crop is fostering a microbial community by growing and keeping your soil a little bit more active. And there's some people that would think that possibly applying manure and lime a little further ahead of when we grow potatoes and on a living crop, perhaps that helps to mitigate issues with scab. So we know common scab is very, in PEI anyway, seems to be very related to pH and to big changes in pH, so big swings in pH at one time. So perhaps, by putting your manure or your lime on a little further ahead, putting it on a cover crop and letting that kind of work into the soil naturally, maybe that has an effect to kind of just buffer any of those severe swings that we see in pH. Of course, I talked about it before. There is a definite benefit socially and environmentally to keeping the neighbors happy. So not having blowing dirt, not having visible gullies in fields as people are driving by in the wintertime and in the springtime. People like seeing the green fields this winter and this fall. I mean, I think there's more fields with covers on them this year than I think I've ever seen. So that's fantastic. But maximizing that, I think, keeps everybody happy. And it's keeping nitrates and phosphates and sediments out of the streams. And that's a net benefit for everybody. So everything we can do that has a long-term benefit to you and your farm, but it has a short and long-term benefit to everyone. I'm going to talk a little bit about benefits to yields a little more in a second. There is also a benefit if depending on your rotation and what how your farm's set up, it's an opportunity to establish a cash crop. So whether it's after potatoes or after, peas or something like that, it's an opportunity to use, winter wheat or fall rye, one of these winter crops to not just as a cover, but as a harvestable crop the next year. And that's so that you're not just investing in covering the ground, but you're also planting a crop that you're going to harvest the next year. Lots of people are doing this already, particularly with winter wheat. There is a growing market in PEI for fall rye, and there's some newer hybrids around that have a higher yield potential. And I know WA Grains is looking for some people to supply them with rye. So, that's definitely an option. We're also, we're going to talk about winter barley a little bit more as we go along. Morgan's going to talk a little bit about that. But, I think there is some potential market for new crops like winter barley, winter triticale, that sort of thing. And how do those fit into rotations? So I'm going to talk just briefly about some work that Dr. Laura Van Erd at the University of Guelph at Ridgetown College has done a lot of work on cover crops in the last number of years. And I was looking at some of the articles and some of her papers on soils at Guelph. So you can Google that and it'll bring you to their website, or you can follow them on Twitter. But they have a lot of good articles that are, most of them are written, for popular press or farm press, so they're very easy to read. And a couple of them talk about, she's done 13 years of cover crops and multiple rotations and different trials, but they kind of looked at the net benefit over all those years. And they have one rotation or one set of rotations that they call it a vegetable rotation, but it had tomatoes in rotation. And when they planted a cover crop directly ahead of the field tomatoes, they saw consistently about an 8 to 12% yield increase in the tomatoes in the year following the cover crop. So remember that 8 to 12% increase in yield. We're going to talk about that a little bit later. But tomatoes are not a wildly different crop than potatoes. They are related to potatoes. They have similar nutritional needs, grown in somewhat similar fashions. They're above the ground, of course, rather than below the ground, but they do have relation. So this isn't wildly different. I did see different levels of yield increase with different crops. That it was higher with the vegetable crop than it was with, say, corn or soybeans, but this did seem to be fairly consistent. Also in their research, they saw that, in a 6-year rotation with 4 years of those having cover crops after the main crop was harvested, both marketable yields as well as the soil health indices were improved with the cover crops. And they saw noticeable increases in organic matter in that short a time. Usually people say, oh, it takes decades to grow organic matter. Well, they were able to show that in as little as 6 years, some of their rotations grew like 0.4 and 0.5%, which is a big deal. So that's important to look at. We are looking at some of that here in PEI in our work as well, but very interesting work. They showed that fall rye was the best cover crop at increasing soil organic carbon. But in terms of increasing yield in the potato crop, all the covers did well, but the best was actually the oilseed radish. So kind of seeing the results of different crops and how they work, I think that's part of what we're looking at here. Some things to consider. Of course, not all cover crops are created equal. Everybody's rotations are different. Everybody's crop mixes are different. So how do you choose what to use? So it comes down to, what species are you going to use or mix of species? Are you going to terminate it in the spring, or is it just going to die over the winter? That matters whether you're doing them after potatoes or before potatoes. Seeding rate's a big one to consider. So the later you seed, the higher the rate. If you're broadcasting rather than drilling, you got to up the rate. So those are some things to think about, and trying to nail down what's the best seeding rate. Method of establishment, of course, like, are you going to put it in with a seed drill? Are you broadcasting it? Are you using an air seeder? What's the best way of making that work in your farm that's not costing you a lot of money and able you to get the ground covered? This is I just borrowed this chart from flow chart from an OMAFRA fact sheet, and I'm going to make this a link to this available on the agronomy site. It's a really good fact sheet all about winter cover crops from Ontario. But this just sort of breaks down, in terms of making decisions on what you're going to use, what kind of cover crops you're going to use for post-harvest. There's lots of things to consider. Growth habits. Is it going to grow, get out of the ground early, or is it going to just keep growing later? How well is it overwinter? Do you want it to overwinter? How easy is it going to be terminated if you need to terminate it? How much does it cost? How easily does it establish? Do you need to do it differently than other crops? Does it need fertilizer? Does it break pest cycles? Does it increase pests? Those sorts of things. So there's lots of things to consider. This fact sheet's good because it kind of gives you this list, but then it also has, for each of the different main cover crop species, kind of gives you a bit of do's and don'ts or things to consider. So that's something to, if you want to check that out, it's very useful as well. So I'm going to stop there for a second and open the floor to questions. If anybody has any questions or comments so far, before I sort of kind of get more into the nitty gritty and into the trial results. Anything unclear about anything I shared, or any questions?
Ryan, just a question on the fall rye. If it was harvested or was it harrowed down to get that yield bump?
That would have been like terminated and worked in.
Right.
Yeah.
Okay.
Yeah. So that would have been, they worked the ground in September, planted fall rye, and then it was planted to tomatoes in the spring.
Okay. Did any of the growers complain about getting rid of leftover rye afterwards? Get it out of the field?
It's definitely one of the crops that I think takes a little more management, but it is possible. There's lots of people that do it. I know a guy in Ontario, a very successful chip grower in Ontario. He uses fall rye before almost every acre of his potatoes. because he's, he can get it on in September. It makes a great cover. It makes a huge root mass, and then he just sprays it before about 2-3 weeks before he's going to plant, and then he harrows it in. So I think it might require a little extra work and trial and error on termination, but it is kind of the gold standard when it comes to fall cover crops.
Yep, very hardy.
Mm-hmm.
Thank you.
John? Your microphone's off there, John. I'll unmute you. Oh, I can't unmute you. You might have, there you go.
Okay, so just to comment on the fall rye, if potato crop is going into next year, that's one thing. What we find with fall rye on last year's potato crop is that we'll get some volunteers growing in our barley crop, and issues like that of having it completely dead, even though it has had Roundup on it. There always seems to be a few escapes, and you can end up with some fall rye, a sprinkle of it in your barley crop or your cereal crop that might be following potatoes.
Right.
So that was just one of the things we've noticed with fall rye.
Yeah, and you're right there. And I know if it's a grain going to feed cattle and it's not going to the elevator, it's not quite as much of a worry. If it's going to the elevator, then you don't like seeing the rye in it. I think that's one reason why we're exploring the winter barley a little bit, to talk about that as an option where people would normally be planting barley instead of rye. So we'll talk about that a little bit too. But that is a valid point, John, for sure.
Okay, thank you.
Any other comments or questions? Don't be shy, everyone. Okay, so I'll soldier on and we'll talk a little bit about the research that we've been doing over the last couple of years on cover crops ahead of potatoes. So cover crops ahead of potatoes, what am I talking about? I'm talking about termination or tillage of termination of the preceding crop and tillage in August or September, followed by seeding a cover crop onto that tilled land. So that's a lot of the time, and historically, a lot of land here didn't get tilled until October, November, maybe after the potatoes came out of the ground and people started plowing or working land, that sort of thing. Some people, maybe they sprayed, they used glyphosate, killed their sod, and they worked it later, or they worked it the next spring, depending on their system, depending on the land, that sort of thing. What we're saying is, can we move that tillage up a little bit into late August, early September, plant a cover crop, and have that established early to get maximum biomass before the cold weather, and really, get a really well-established, big, thick cover crop of something that isn't going to be a challenge to deal with the next spring. So something that's likely going to die over the winter or die by the next spring, and then it's not going to be a challenge to get your land prepared before potatoes. If you're planting in August and September, it allows you a greater choice of species or mixes, so you're not as restricted to just grains and winter grains and that sort of thing. You've got a lot more options, and it's getting some of that primary tillage out of the way at a less busy time of year. So for a lot of growers, August to September, we're definitely not into full potato harvest yet. There might be some people picking away at some of it, but hopefully you've got a tractor or two that's available. You got a person or an operator or two that's available, and it's a little less stressed time of year than right around harvest time. So and then in the spring, a lot of people have found by doing this type of a process that maybe they only have to go one cut on that ground ahead of the planter, and you're maybe cutting a tillage pass out of the system as well. And that has economic benefits for you, but also has soil health benefits as well. Any place we can reduce tillage. So the Living Labs initiative, I know I've talked about that several times in presentations to you folks, different meetings and that sort of thing. So it's a project that we're 2 years into. It's a partnership with Agriculture Canada, East Prince Agri-Environment Association, a number of different parties. So there's watershed groups, there's into other researchers from universities and other government departments. We've got lots of different people involved. Specifically, the board is leading 3 projects. So Morgan and I are working on 3 different projects: cover crops ahead of potatoes, cover crops after potato harvest, and soil building full season crops. We're going to talk about the first 2 today, which Morgan and I call BMP1 and BMP2. BMP3, which is the full season cover crops or full season soil building crops, we're going to talk about in another meeting later this winter. So I'm going to talk about this BMP1, which is 6 fields that were set up in the fall of 2019, and then they were tracked through to potato harvest this year. And then we also set up 8 more fields in this trial this year that'll be in potatoes next year. So these are the different fields we had last year. We had oats compared with the check. We had oats and a mustard mix compared to a check. The check is always no cover crop, so you know. We had brown mustard, barley, and oilseed individually compared with the check, barley broadcast compared with the check, and oilseed radish and mustard separately compared with the check. One thing you'll notice here, we have one of these fields was in August, and the rest are all in September, and they're all in the second half of September. That is largely because, well, I probably have these out of order, but as a lot of you will remember, last fall was very dry until the very end of August. And so it was very hard to get land worked because the land was so dry. And if you seeded anything, the cover crop might not have grown anyway because there wasn't a lot of soil moisture. And then we had a big rain just before the hurricane, and then we had the hurricane, and then a big rain after the hurricane. So the soils were saturated for a long time, and it wasn't until the second half of December that people could get back in to plant and work ground without doing damage to the fields. So that's the main reason that, you know, these are a bit later than normally we would have liked. But the ones this year, most of the ones we planted this year are in late August or early September. So because weather will cooperate a little bit more this year for making that happen. So what did we see from last year's fields in terms of trends? As we expected, we can't really see a visible effect of soil organic matter in 1 year. We'd really need to look at this over many fields over multiple years to see a lot of individual difference just from the use of one cover crop. We are tracking this though every year, and we're doing this testing because we do want to see whether we see, you know, once we get to the end of this project, do we see a trend or the start of a trend? Do we see a difference? We didn't see any difference in soil nutrition or nutrient availability. So things like P and K and you know, micros and that sort of thing. We didn't see a difference in 1 year in soil health metrics, but I will say it's hard to measure that a little bit in this trial because we were measuring sort of summer and fall versus in the spring before the potatoes were planted. And those time of year differences can have a big impact on comparing soil health or soil organic matter or any of those sort of things. Generally, if I want to compare year after year, I want to compare, you know, the same time frame each year. So if I do it in, you know, the spring, I want to look at it against the next spring to sort of control that time of year effect. We don't have that luxury in this project, so we went forward and did it anyway, but we didn't see a big difference. I will note that 5 out of the 6 fields that were in this project were mostly rated low for those soil health metrics. So these were fields generally that growers said, oh, these are fields that need a little bit of help. So, you know, that's something to consider. We did do soil nitrate analysis in these trials as well at 3 different depths. Didn't see any real trends there. And in most of the fields, the nitrate levels were undetectable, both in the check and in the cover crop. So that kind of tells me there wasn't a lot of residual nitrate in a lot of these trial fields, or it was all gone before we were able to sample. But we sampled reasonably early in some of these fields, so I don't think that was the case. And verticillium and nematode numbers are very field specific, and I'm going to talk about that a little bit more as we go along. I already talked a little bit about, you know, the lateness of the fields being established. One proviso I'll put on this, of course, that, you know, any data I share with you, any trials that I share with you, it's just 1 year of data. So try not to make sweeping judgments or sweeping, changes based on 1 year of data. It is multiple fields in multiple parts of PEI, so we do try and control that variability a little bit. But we'll have more data coming in the next 2 years to add to this. So hopefully we will be able to, you know, validate whether those trends remain the same. And we haven't applied any stats to this data yet on a field by field basis. We're just kind of showing you trends. We will be doing more statistical analysis on this as we build more data and we get further along. So some trends we did see in the last year. So across 6 trials, we saw a positive trend on yield improvement. So what I did is I took each of the different treatments across the 6 fields. A couple of fields had multiple treatments in it. And when we took the yield from the treatment versus the yield from the control, and I took the differential, and then I averaged the differentials over all of the treatment mixes, the difference in total yield is an improvement of about 2,500 hundredweight an acre. And on marketable yield, it's about the same. It's 2,400 hundredweight an acre. That's very interesting. I'm going to show you the graph of that a little bit more in a second. If we take out the 2 fields that didn't establish properly due to late establishment, one of them was mustard, and the other one was mustard and radish, and they were both established late in September and had very little amount of ground cover. We take those 2 out, our trend is more like 40 hundredweight an acre. So that's very interesting, and I wasn't expecting it maybe to be quite this high, but if we look at these numbers, you know, 25 to 40, that has us in that 8 to 12% range, similar of yield improvement, similar to what they saw in Ontario. So we're not wildly different than the numbers that they saw in Ontario. We're kind of in that same range. You say average yield's 300 hundredweight, yeah, we're probably somewhere in that ballpark. So I just kind of graphed these out. So you can see there's 2 fields that showed a negative marketable yield on the covers compared to the check. But as I said, this field did not establish properly. It had, because it went in so late. And you know, this one in particular is probably not significantly different than 0. All of these ones are probably not significantly different than 0 if you were doing the stats on them. This mustard one also, I wouldn't put too much faith in this 10 hundredweight because it also, you know, the mustard barely grew in it. So that's probably just random sampling. Didn't see much impact on this barley. But then we get to these ones, and there's, you know, we have a couple here. This one's up almost 70 hundredweight. This one's over 60, you know, over 50, just under 20. And that gives us an average around this 25 hundredweight for over all of them. So, you know, probably these 3 here would, you know, if we do the stats on them, they'll probably will be statistically significant based on what we see, based on that amount of difference. So, you know, again, not going to completely hang my hat on it and not saying that, you know, the yield benefit is definitely 25 hundredweight, but it does look like we have a positive trend and that it's generally positive and not too much in the way negative. I'm going to go into a couple of specific field sort of case studies and show you a little more of what we did. And then after I go through these case studies, I'm going to stop for a second. And if you have any questions, then we'll stop for that too. So the first one, this was the earliest planted. So this was planted in late August, and it was and had mountain gems in 2020. And you can see by planting it that early, this percentage of cover is terrific for the mustard and oat mix. So by November, we're up almost 75% of the ground was green in terms of the photography we did, compared with, you know, next to 0 for the check. Even in late, you know, 2 weeks later or so, it's gone down a little bit. Probably had a couple frosts on it, that sort of thing, but it's still, you know, very, very good, and it's providing a lot of ground cover. It's very active cover crop. Morgan's going to talk a little bit more about this in specifics, but we've been measuring the erosion potential of these fields with splash pans, and she's going to have some photos to show you that a little bit later on. But over 6 weeks in the cover crop, we only had 5 grams of soil per pan that we found over cumulatively over those 6 weeks. So that means that cover crop, when rain's falling down onto the ground, it's got so much cover that it's protecting from water hitting the surface of the soil and causing soil to bounce back and go into the pan. That's compared to almost 40 grams per pan where we didn't have a cover crop. So that just shows from impact of water, rainfall on the soil, what the improvement in erosion potential is. When it comes to verticillium, we didn't see a difference in the check. We did see an increase in the mustard oat side in the spring. I wouldn't get too excited about that yet, just because verticillium testing, I find, can fluctuate quite a bit, and don't have a lot of evidence that mustard or oats are a big multiplier of vert. So I'm going to kind of see where this trend goes maybe in other years. On the root lesion nematodes, we didn't see a difference from the mustard oat side in the spring, but the check went from almost 5,000 to over 12,000. And I can't really explain that other than what I think might be going on is that, of course, before any of this was done, I think there was a sod crop in this field. And when it was worked in, even after it was worked in and even after stuff was growing in the fall, there's still residue and roots from that past sod crop that a lot of nematodes would be living in. And so when we soil sampled in the fall, last fall, this might not be an accurate reflection of how many nematodes were actually in the field, because a lot of them might have been in the roots of the previous crop compared to what was free living in the soil in the spring. And we see that trend in a few other fields, so I'll show you that a little bit more in a second. So that's what that crop looked like. You can see like there's lots of oats here, but in between the oats, there's lots of mustard that was growing, and you've got really good coverage of that soil. Very little red showing. So this is the yield information and the yield and quality information for that trial. So you can see the check and the mustard oats. We've got about 27 or so hundredweight difference in total yield. Not much difference in smalls. The 10-ounce percentage was better on the mustard and oat side. No difference in gravity. And then, about an 18 hundredweight or so improvement in marketable yield and about a $230 improvement in payout from side to side. So, in that same range as what we saw across all the fields, somewhere in that range. This was another trial that we looked at. This field was in the east, and it was oats broadcast on a plowed field. And this was done on September the 27th. And the potato variety this year was Nadine. And so, again, you see the last field was August. This one's September. Our percentage of green cover is much lower. But there's still a value to having, 14, 15% cover in early November. There's still a lot of green matter to keep that ground covered and a lot of root mass to hold soil. One thing we did see, Morgan and the watershed team went in and did penetrometer readings this spring. Last fall, the penetrometer readings were basically the same on either side, but this spring, you can see the average penetrometer reading at 12 inches is massively lower than it was on the check. So that kind of tells me that, those oats, the roots penetrated down to 12 inches or so in the soil and helped break up that soil a little bit and just helped with that compaction. And maybe that helps to explain some of the yield improvement I'm going to show you in the next slide. Vert, it decreased on both sides, which kind of makes sense because their oats are not a host crop, and the check crop, the check isn't multiplying vert either. The nematodes, again, they increased. And again, I think they increased on both sides. I think that's probably down to, again, these numbers in the fall are probably underestimated, and these ones in the spring are probably a little bit closer to reality. it was interesting that the numbers are much lower on the outside than the check side. Not sure I understand why that is, but something to consider. This is what the field looked like. So you can see this is our, the middle is our check, and the sides is where the cover crop was. And I think this was taken about mid-November, and there's a, you know, a reasonable amount of carpet, green carpet here. It's not huge, but it's decent. What's very interesting was the yield information that we saw. So we had, you know, a 5,500 weight yield improvement on total yield, and almost a, you know, over a 6,000 weight, or sorry, 5,300 weight yield improvement on marketable yield from the oats versus the check. The oats had fewer smalls. This, you know, looks like the trend here. That's probably very close to statistically significant, maybe not quite. I would say there's no difference in 10 ounce. This is probably not statistically different either, probably just random. But it does appear that there's a difference in yield. And if we attribute that, a payout to that, on this is a table stock crop. So what I did is I multiplied the marketable yield by last February's GRI of 1730, 100 weight, and that gets us these marketable yields. Those might be a bit high. It's an imperfect system for calculating a payout on a table variety, but it's applied the same on either one. So no matter what number we use here, the percentage difference is still going to be the same. So, but it's you know, using this calculation, there's about a $900 difference from side to side, and that's quite striking. And the last one I'm going to talk about was this one would kind of surprise me a little bit. So this one was, again, this was the latest established one that we had. This one didn't go in until September the 30th. It was barley and oilseed radish separate strips compared to a check strip. Most of the field was barley. There was a decent sized check, and then a check of oilseed radish. And this was Gold Rush in 2020. This field was a very low organic matter field. I'd say fairly shallow topsoil, planted late, low soil health ratings. That will impact the yields you see on the next slide. What surprised me though was even by November the 18th, despite some of this late planting, the radish and the barley still, you know, they still came along. They didn't do great, but they still had, you know, better than the check. The check, this was just a few weeds that grew up, and maybe a little bit of volunteer grass. This is, you know, it did show some that grew, and it did help, you know, protect the soil a little bit. On the verticillium, I was surprised that there was a big variation here. Again, this may be down to sampling a little bit. I can't explain why it would be way higher on the barley side than the check and the radish, because barley is not known to be a host for vert. So not sure really what's going on there. Vert and nematode numbers, I think, sometimes can be a little bit wonky. And then again, we saw that same trend that we saw in the other two fields, which is the fall nematode numbers were much smaller than the spring nematode numbers. And again, I think part of that is, I think these are probably an underestimation. So we'll keep looking at that trend, and we may even look and see in it whether, if we can identify fields earlier, whether we can do spring versus spring or fall versus fall in some of these fields for looking at nematode numbers. This just kind of shows you, this is what did grow. So Morgan took these photos on November the 18th, and you can see there's a lot of red here, but there is a bit of a cover crop. This might have looked a little bit better earlier in November. It, you know, probably impacted a bit by a few frosts, that sort of stuff. This is the radish. So it's not great, but it is, you know, there's something there. These are our Canopio pictures. We use an app called Canopio to calculate the amount of green cover on a field. Like it basically identifies all the green pixels in an image, and that gives you a percentage. So Morgan ran these, and, you know, the numbers here are pretty close. You can see there's a little difference. The barley, it's a little more evenly spaced through the field. So there's there's a pattern. There's no clear pattern. It's just sort of evenly distributed, where the radish is maybe a little more clumped, but each individual plant has a little bit more green matter. So maybe each individual plant's a little more vigorous, but there's a little less of it around. But when we got to look at the yields, there does look to be a yield benefit for both of the cover crops compared to the check crop. And this surprised me. I didn't expect, with these going in that late and having that level of coverage, that we would see these type of yield improvements. And there wasn't just a total yield improvement, but there looked like both of the check and both the radish and the barley were a little better for the percentage of smalls. Not much difference in 10 ounce or defects, but that carried over to this marketable yield and carried over to a payout. Again, I used a table stock calculation to do the marketable or to do the payout in this field because it was gold rush. Yields are very low because of, this was a very dry area. It was gold rush, which we know has a problem with early die. It was a challenged field, but there does seem to be some difference here, which was very interesting. And I could say that this was a reasonably large field, but we controlled the variability a bit by we took the barley was probably 2/3 of the field, but we took our samples right next to where the check strip was and right next to where the radish strip were. So we weren't actually very many rows separate from each other when we were taking these samples. So it wasn't like we were doing one side of the field versus the other or anything like that. So just before I open it up to questions, I'm just going to say for this year, Morgan and the growers set up 8 more fields in this trial. So we have a field that we're comparing oats and radish by themselves, and then an oat radish mix versus no cover check. We have mustard radish mix versus a check at 2 different places. We have tillage radish versus check, as well as a killed sod that's not going to be tilled up till the spring. So in this field, it was a sod field that was sprayed with glyphosate, and part of it was tilled and planted to tillage radish or just left open with a check, and then a bunch of it is going to be tilled in the spring. And I think that'll be an interesting trial. It went in a bit late for the radish than I'd like, but it did still emerge and it did still grow. We have barley versus check following more plow. We have oats and buckwheat stubble versus check. So again, there was a couple of different treatments in this field the year before, but we will have something to look at here. And this also went in late, but we'll have a seat. It'll give us an idea of how well those oats did with late planting. And then we have tillage radish and mustard individually versus a check at 2 other places, and those went in pretty early, and had really good coverage. So we should have some good data there too. So I'm going to stop for a second. Does anybody have any questions about anything or comments about anything I presented there? And please feel free to unmute yourself and ask a question or raise your hand or anything you have. John?
I guess, yeah, just a comment there on that trial that you're going to do comparing the residue tillage by itself with cover crop and one that's left till the spring. When we're getting these cover crops in before potatoes, we always feel there's a trade-off by having to desiccate maybe a growing clover, alfalfa, green manure crop that's building, soil fiber and everything, desiccating that in order to get the fall cover crop established in time. So I think comparing all those would be fairly interesting and raise the question of how much are we trading off from killing our green manure hay crop early compared to leaving it until it's fully grown and mulched a couple of times and maybe desiccating a little bit later and not getting a fall cover crop on. So I think that trial with those three different methods are going to tell us something very interesting. And
yeah, we
have noticed as well that in the spring, leaving a sod field that's desiccated and leaving it until the spring is great for winter cover. We also have found that the soil can sometimes be go go a little bit lumpy on you by leaving until the spring. I'm not sure the reason for that, and maybe it's what we've learned is that if it is in the spring, make sure that you don't do it too early.
Right.
We love to get our old board plows out in the spring, the end of April, whenever the snow disappears, to get some of that fall plowing done in the spring. But with residue tillage, that would be a no-no as far as what we've learned. So
right. So in particular, this farm that was part of this trial, historically they do most of their tillage in the spring. They generally have, and which has a lot of benefits for erosion and that sort of thing. But they were finding that they were getting a lot of lumps, and maybe they wanted to explore doing this more of a fall cover crop process to get the land worked in the spring. And how does that compare with what they normally do? So I think that that should be kind of interesting.
Yep.
Any other comments or questions? Don't be shy, folks. I know this is an easy opportunity to be shy, but welcome any comments or questions you have.
Ryan, I just have one comment on your nematode numbers there.
Yep.
I know we've talked about it before, but I really think you should be sampling in the middle of the season. Like all the work that we've done, we've seen this a pretty well-defined bell curve, and so when you're looking at spring versus fall, you're kind of opening yourself up to some of the other characteristics in the field, like if it's south facing, high versus low, like all these things that basically anything that affects water is going to affect your nematode populations. So what we found is if we're sampling in the middle, which is basically the top of the bell curve, everything's kind of stabilized with the plant communities, and it kind of gives you a good idea of what the populations actually are. So if you were to look at the middle of the season, rather than like there's all kinds of things going on when you have to till, you have to seed, there might be treated seed, there's all kinds of things going on. So usually from year to year, the best way in PEI anyway that we found to compare those nematode populations is to look at things when everything's in bloom, whether it's potatoes or barley or whatever, like when it's at flower. And we find that things are a bit more stabilized. We'll get higher numbers, but we find that it's more representative of what the actual number is.
Yeah, it's a good.
So just something to keep in mind.
Yeah, it's a good point, Aaron. Like, little bit constrained by the way these fields are selected and picked, and when they're started. A lot of them aren't seeded or aren't established until late August and September, and so it's harder to get a mid-year number unless we identify what field we're going to do the trial in really early, which we are trying to do. We're trying to get those identified as early as we can. And so I'll take that point. That might be something we would look at. What we may look at doing is also just trying, if we can't do it mid-season, at least try and have when we take it be the same. So if we're doing it on September 1st, maybe we should have a sample on September 1st in the potato year. I know they will have had a chance to multiply in the potatoes all year, but at least we're controlling the time of year more. I know we've done that with some of our other trials, like some of the longer term rotation trials we've done through AIM and that sort of thing, where we are, we're doing spring versus spring or fall versus fall, so that we are at least maintaining the same time and the same sort of, rotation dynamics, those sorts of things. But, I take your point. I think if we can try and, level the playing field, it helps us to see whether there's any real trends going on there. Any other comments or questions? Okay, hearing none, and there'll be lots of time at the end too if there's something else that percolates. But I'm going to turn it over to Morgan, and Morgan's going to walk through the cover crops after potato work that we've done.
Good morning, everyone, and thank you for joining us today. I'm going to talk about the fall cover crops after potatoes. And as Ryan mentioned, this is part of the Living Labs projects, and this is looking at BMP2. So I'm first going to outline some of the different types of research trials that we would do through the fall cover cropping after potatoes. So we are looking at different trials, examining things like different species of the same crop, such as winter barley versus spring barley, looking at trials with different seeding dates of the same crop, perhaps one being 2/3 of the other, and also looking at different seeding rates of the same crop. So we have date comparisons, rate comparisons, and species comparisons. And I just wanted to note the importance of fall weather conditions as it pertains to setting up these trials to get successful establishment of the cover crops. Right, yeah, thank you. So I'll start by talking about some of the trials that we established in 2019 last year. So last year we had 7 trials in this project, and we had crops including oats, fall rye, or barley. So last year we had 1 rate comparison looking at 2 different rates of a cover crop, and then the rest of our trials just compared 1 or more cover crops to a check strip. And in these trials, we measured the fall soil chemistry, we measured the soil nitrates to 3 depths, as I'll get into shortly, and we measured the soil erosion potential with the splash pans, and we also took photography using a Canopio app to measure the % ground cover that was green. So I'll begin by talking about some of the soil nitrate results from the trials in 2019. And so I'll begin looking at general trends, and then I'll go into a few case studies on some specific trial fields. So looking at this generally, we were able to see that there was more nitrates that accumulated from the check strip as opposed to that from the cover crops. So this generally showed that it was beneficial to have cover crops in these trials. And then when we looked at the 3 depths that we soil sampled to, including 0 to 6 inches, 6 to 12 inches, and 12 to 18 inches, we found that the nitrates were greater in the lower 2 depths, including 6 to 12 and 12 to 18 inches. And we found this particularly at the earlier time points in mid-October or early November compared to the middle of November. And we saw this trend regardless of whether it was in the check strip or the cover crop. And I just showed at the bottom here the range, and it was anywhere from less than 5 parts per million, which we would deem undetectable, up to 21 parts per million. And so here I'm going to do a brief overview of some of the results we saw from a nitrate case study in one of our fields from 2019. And so this first field that I'm going to talk about was planted on October the 14th, and it was comparing a fall rye crop to a check strip. And we found that in mid-October, we had more nitrates from the rye crop in the top 2 depths that we sampled, but we had more nitrates in the 3rd depth in the check strip. And so this goes to show that the cover crop did a good job at holding on to the nitrates at that time point in the season, in the fall. And then when we looked at some of the results from early November, we found that there was more nitrates in the check at all 3 of the depths. And so now I'm going to briefly talk about a second trial for a nitrate case study, another field in 2019. And this other field was planted on September 30th. And in this trial, we looked at comparing 2 different rates of barley. One seeded at 85 pounds per acre and one at 120 pounds per acre as compared to a check strip. And we didn't see any general trends to point out specifically between the two rates of barley, but we did find in early November that the nitrate levels were higher in the check strip than either of the two barley treatments. And now I'm going to briefly talk about some of the trials that we established this fall in 2020. So this year we had cover cropping after potatoes with crops including fall rye, we had winter barley and spring barley and oats. And one thing I'll point out this year is that we did end up having a better variety in different types of research trials than we did last year in 2019. So this year we had 3 trials that did a species comparison of spring barley versus winter barley. We had 2 trials that looked at different rates of a cover crop. And then we had 1 trial looking at method of establishment of seed and cover crops. And same as what I talked about before, in these trials, we also measured the fall soil chemistry. Again, we measured nitrates, soil erosion, and we did Canopio photography. For this set of trials, we're still waiting on a lot of the results from the labs for the nitrates. So we are going to focus today's discussion more on the other results that we have to date. So this might be a good point to pause for a moment if there's any questions or any comments from anyone online.
I'm Morgan. Can you hear me?
Yes.
It's William Visser. Just a quick question. What depths were you sampling for the nitrates? You said on the 2 upper depths you had a little more in one case, and lower depth you had more. What depths were the different samples taken?
Yes, excellent question. So the 3 depths that we sampled to included 0 to 6 inches, that being the top depth, and then 6 to 12 inches being the second or the middle depth, and 12 to 18 inches being the lowest or the third depth. And I think I have them written on one of the previous slides. Yeah. Are there any other questions or comments?
All right, keep going, I'd say, Morgan.
All right. So now I'm going to run through some of our winter barley trials. And I'm just going to show you some photos and we'll talk about a few of the details for each trial. So this first one that we set up this fall was in the Surrey area. And we were comparing winter barley as shown in the photo on the right to a winter wheat crop pictured here on the left, as well as it compared to a check strip. And this field was planted on September the 28th, and the seeding rates included 190 pounds per acre for the winter wheat compared to 120 pounds per acre for the barley. And we saw in this trial that the barley established a few days ahead of the winter wheat, and over the first few weeks of growth, they were fairly similar in their rate of establishment, although by the middle to late November, we saw that the barley got ahead of the winter wheat in terms of the Canopio photography that we examined. So this is another example of a winter barley trial we did this fall. This field was set up in the Kensington North area, and we're looking at a winter barley crop pictured on the bottom left corner as compared to spring barley and a check strip. And this trial was planted on October the 8th, and the seeding rate was 100 pounds per acre for both the spring barley and the winter barley. The one thing I'll note is that the winter barley was drilled in whereas the spring barley was just broadcast or spun on 5 days ahead of the planter. And this third example is another winter barley trial that we set up in the East Prince region. And here we were comparing winter barley and spring barley against a check strip. And these photos below, the one on the left-hand side is showing spring barley farther on the left beside a check strip. And the photo on the right is showing a check strip kind of toward the top left-hand corner, and then the winter barley beside that. This trial was planted October the 1st, and the seeding rate for both the winter and spring barley was 100 pounds per acre. And in both cases, the winter and the spring barley were just broadcast on. So I'll just pause there for a moment if there was any questions or any comments before we move on to the erosion data.
So this was our first shot working with winter barley, and the agronomic advice I got from some people in Ontario, like Wheat Pete, told me that it needed to go on late September or early October at the latest. So that's kind of what we targeted for, and I think, you know, we were able to make that happen with the 4 growers we worked with. And our hope is to harvest a bit of this next year. Hopefully it lasts the winter. And grows well in the spring, and then we can harvest some of it, and then we'll have a little bit more winter barley to go into some trials again next year. But I know yesterday we had quite a bit of chat about, you know, where winter barley might fit in different systems and different rotations. We talked a little bit about, you know, people doing some frost seeding in this, you know, before the spring to put a underseed underneath it, so that then they wouldn't have to do tillage the next year. For like what John was talking about earlier about having a, you know, not growing rye because you don't want to, you know, you don't want to have rye contamination in your barley that you normally grow. This might be an option for some of those fields if we can show that it consistently establishes that sort of thing. I don't think you can plant it as late as rye by what we're seeing so far, but we'll know a lot more in the spring how well this survived the winter. So,
could I ask what variety? I missed that. What the variety was?
Oh,
The winter barley.
I'll have to look that up, Aaron. I'll look that up and get back to you.
Okay.
Are there any other questions or comments? Well, I'll continue then, and if any other questions come up, just let us know. So now I'm going to talk about some of the soil erosion data from the trials in 2020. I first just wanted to show a few photos to give you guys an idea of what this looks like in the field setting. So here we have 3 photos, all taken from the same trial in the Surrey region. And the photo on the left is showing a erosion splash pan on a radish crop. The photo in the middle is showing a splash pan in a check strip where no crop was seeded. And the photo on the right is showing a splash pan in a cover crop of oats. And as you can see in all 3 of these pictures, they were all taken on the same date for consistency. There had been some water that accumulated in the pans with some soil splash that accumulated underneath as sediment in the pan. And so the idea with this test is we would use a little syringe to take out as much of the standing water at the top as possible at different time points when we check on them. And then we come in with some paper towel and wipe out as much of the soil as we can take out. And then we dry down all of the contents that we take out of the pan. And then we do a few calculations to determine the amount of soil sediment that has built up over time. So I will briefly talk about a few case studies from some of the trials we looked at this fall. The first trial we had planted on October the 8th, and we were doing a comparison of winter barley crop to a check strip. We installed splash pans on October the 22nd, and we left them in the ground over a period of 4 weeks. And in that time, we were comparing the soil that accumulated in a barley crop to a check strip. And we can see from the numbers that there was 125 grams of soil that accumulated in the barley versus 149 grams that accumulated in the check strip. So this goes to show that more soil accumulated in the check than it did in the barley. And this seems to support the use of cover crops to prevent erosion. And now I'm going to talk about a second case study from another soil erosion testing site this fall. So this other field was planted October the 1st, and we were comparing a fall rye crop to a check strip. And the pans were also installed here on October 22nd, and we had them in the ground over a 4-week period. And so we were looking at comparing a rye crop to a check strip. And we saw that the amount of soil that accumulated over that 4 weeks was almost the same. It was very similar between the two treatments. And although we had very little difference, we tried to look at other characteristics to answer the question of why we didn't see much difference. And we looked at soil health data for this site, and we saw that the soil health results were fairly good. The soil had fairly good organic matter levels. It had strong aggregate stability. So this might have prevented us from seeing more of that difference between a check and a cover crop. So that's just something we're going to keep in mind as we move forward with these research trials, because we have to look at the results on a very site-specific basis. And you can't necessarily compare fall rye to barley in different sites. So. Now I'm going to show you some Canopio ground cover photography from some of the trials that we looked at this fall. This first example is looking at one photo from each of 3 different trials, and these pictures were all taken the same date on November 17th, and each of these pictures is showing a spring barley crop. What we can see in the first photo on the left-hand side is spring barley that was planted October the 1st. In the photo in the middle, it was spring barley planted October 8th, and the photo on the right is spring barley planted October the 12th. And we can see that as the planting date gets later, the ground cover has quite dramatically decreased. So going from about 44% ground cover planted on the 1st to about 20% ground cover, something planted the 1st to 2nd week of October. And as you get closer to the middle of October, the Canopio results were much lower. So I just want to point out the importance of planting date with the success of the cover crop establishment. This is another example looking at some of our Canopio photography results. And in this example, we have 3 photos that were all taken from the same trial. All these pictures, again, taken on November the 17th this fall. And in this trial, we were comparing a fall rye crop that was broadcast after potato harvest, and another one showing a fall rye broadcast before potato harvest. And then we have a check strip in the middle. And what we can see from these results is that the fall rye that was broadcast after potato harvest, results were not as high as they were in the fall rye broadcast before harvest. And we can also see that the fall rye broadcast after, the Canopio picture showed it to be fairly evenly spread so that there was not as many clusters, as opposed to the fall rye picture broadcast before harvest. We see thicker spots where the seed came up denser, and then a few spots where it's a little more patchy and there's not as many fall rye seedlings. One thing I'll also note is that the fall rye broadcast after harvest was leveled, as opposed to the one broadcast before that was just left after it was seeded and after harvest. And then the photo in the middle for the check strip that had no cover, we only see about 3 to 4% ground cover, And what we're just picking up here is little bits of grass or weed seedlings. So it was a very minimal amount. And now I'm going to talk about one other example. And in this set of photos, we are comparing a spring barley crop to a winter barley crop that were both grown in the same trial, the same field, and again, comparing it to a check strip. All three of these photos were taken on the same date, November 17th, and it goes to show that the winter barley did much better than the spring barley, both planted on the same date, and we saw anywhere from 19–20% for the spring barley, and then for the winter barley, we had about 44% ground cover, so that was more than double. And the check strip, again, had very little cover and a very small percent Canopio result. And the one thing I'll mention, the important point here, is that given that this field was planted after October 5th, we definitely saw better results with the winter barley as compared to spring barley. And so we suggest that the winter cereals established better than the spring cereals seeded after October 5th. So now I'm just going to briefly go through a few of the results in a graphical form for 2019 trials and then 2020 trials. So I'm first going to look at the graph on the left-hand side, where we are comparing the planting date with the percent green ground cover through the Canopio photography. And we're looking at 3 cover crops, including oats, spring barley, or fall rye. You can see the scale on the y-axis for the percent ground cover was quite small, only going up to about 18%. We can see from the data from last year that we had a cluster around 6 to 10% ground cover. We did have fairly low numbers last year through this analysis, and I think in large part we can attribute it to the weather conditions. As Ryan said, they weren't the most suitable, with very dry conditions in August, leading into a lot of heavy rainfall in September. So we had to work around those weather conditions in order to get the ground worked and crops seeded in a timely fashion. And we have a few outliers, some of the other crops, but generally speaking, we had much better results in 2020 with better fall weather conditions. So when we look at the graph on the right-hand side, again, comparing planting date to the percent green ground cover, we are looking at oats, spring barley, and fall rye again, as well as looking at winter barley, which we did not have in trials in 2019. And so we can see in the graph here on the right that any of the trials that were seeded before or leading up to October the 1st had the best establishment for the percent green ground cover, anywhere from 40 to 50%. And then we can see that after October the 1st, we gradually see less establishment of the cover crop with a much lower percent green cover. And just looking at the different crops, we do have a few outliers, but generally speaking, earlier planting date resulted in the best cover. And finally, I'm just going to look at some overall trends from the data in 2019 and 2020 put together. So we're going to have another quick look here at the 4 cover crops that we were examining before: oats, winter barley, spring barley, and fall rye. And one thing that really stood out to us is definitely the importance of planting date for better establishment of these cover crops. We did see that the winter barley overall was our best in these particular trials, in that it had the best establishment for the percent green ground cover with Canopio, and especially at earlier time points, but also progressively later on. We see that the oats, we only had a few trials with oats, so we had limited results to report on here. But with the spring barley and the fall rye, we did have our best establishment when they were seeded earlier in the fall and progressively lower percent cover as planting date got later. So overall, we'd say the winter barley did the best, but we will be following this up with other research trials in years to come to see if those trends stay the same. So I think here we'll just take another quick break to ask for questions. If there's any questions, any comments, anything you guys would like to talk about.
Morgan, I have a question about your seeding rates.
Yes.
So for example, in one of the trials, there were different seeding, there was a higher seeding rate with later planting. And then the next photo, it was a Canopio photo, but it didn't say what the seeding rate was. And I was just kind of curious to know what your findings were on seeding rates.
Okay, excellent question. The slide that I'm thinking of was looking at, yes, the spring barley, 3 different trials looking at the planting dates. So for this example, the first 2 photos show a seeding rate of 100 pounds per acre. And the third photo is showing 150 pounds per acre. So for this example, we're not looking quite specifically at the seeding rate necessarily. We do see though where this third photo, this third trial, it was planted a little bit later than the other 2, and therefore the seeding rate potentially was increased for that reason to make up for it being seeded later. However, we see that even with that higher seeding rate, that it didn't establish as well as the previous 2 photos, the previous 2 trials. So I definitely think the planting date was a more important factor here than actually going to increase the seeding rate, because we need to give the spring barley enough time to get established while the weather conditions and the temperatures support its growth. So what we're finding is that if you leave it late enough in the fall that you don't get it seeded on time, then even when you increase the rate, it's not going to make a difference.
Okay.
This one here too, this one here, those are 3 different fields, so 3 different individual trials, but Morgan was just trying to kind of show the difference, the effect of seeding data on percentage of ground cover. This one, these are all from the same field. So I think, Morgan, you can correct me if I'm wrong, I think the seeding rate was the same on both sides of this field, whether it was broadcast before or after.
Yes.
Yeah, so and I don't know what the seeding rate was off the top of my head, but it was definitely over 100. I think it was probably more like 150, but yeah, that one was the same on both sides. And then this one, this is from the same field too, right, Morgan?
Yes, it is.
And I think the seeding rate was pretty close, if not the same on this one as well. I'm pretty sure both of these were about 100 pounds an acre.
Yes, they were 100 pounds per acre each.
Okay, thanks.
Any other questions for Morgan?
I was just wondering about if you're broadcasting before harvest, if you went 4 or 5 days before you plan to go through with the harvester, does that help with any of the ground cover?
We haven't particularly done we haven't done any trials yet where we're looking at the amount of time before harvest that it's spun on. That might be something to look at in another year if we have a grower as part of Living Labs that would like to look at that. Maybe we can kind of build that into a trial, like compare 4 or 5 days ahead versus say 2 days ahead or the day of or something like that. A couple of the fields where it was put on ahead of harvest, it was put on 3 or 4 days ahead of harvest. But we haven't done a specific trial on that, so maybe that's something that we could consider for another year. Any other questions? Okay, I'm going to just give a little bit of an update on fall hilling. I've talked about this a couple different times at AIM meetings in the past, and so I'm not gonna belabor the background a little bit. What we've talked about in the past is that Why would we look at fall hilling? Well, again, it's an opportunity to get land worked a little earlier, maybe at a less busy time of year. It's an opportunity to get early establishment of a cover crop. It might be an opportunity to reduce tillage passes. If you got those hills made in the fall before, in the spring, you might not even have to do tillage ahead of planting, or very minimal. And it's an opportunity to incorporate your potash or your lime, before you hill, and that maybe that incorporates or mixes that those nutrients and those amendments a little bit more through the soil profile, that sort of thing, and get that done ahead of time as well. These are just a couple of pictures from the first couple of years of the trials we've done. So this was the first year that we had a grower do it. I think I've shown this picture before. So in this case, the barley was spread on before the hilling was done. And that meant that, there's lots of barley on the top of the hill and not very much in the furrows. So then the next year, these were taken different times after planting, of course, but the next year, the barley was put on after the hilling was done. And in this case, there was a lot more barley that was growing over the entire field, like down in the furrows and over the top of the hills. And this grew to a decent size, by November, that sort of thing. And this was barley, of course, because then in the spring, it'd be broken down to, it'd just be some wispy stuff that's pretty easy to incorporate. So this is data that I've shown before. This is the data from the first 2 years of the fall hilling we've done. And I guess what I would, we had 6 different fields over 2 years. What I draw your attention to is that we've seen a trend of a marketable yield increase of about 1,800 weight per acre. And only one of these fields was negative, 5 were positive, and the ones that were positive were generally in a similar range, that sort of thing. Again, same for payout, only one was negative. So there seems to be a trend towards increased marketable yield, or at least the very least, looks like there's not a negative impact of using fall hilling. Possibly some slightly fewer defects on the fall hilling side. But anyway, so far it looks like a little bit of a marketable yield increase. So 2020, we had one field that was set up in 2019, hilled in 2019 for potatoes this past year. Was planted in late May. Russet Burbanks was hilled mid-October last year, so it was actually quite a bit later than other years that we've done it. So, and because it was done late, they weren't able to get a cover crop established. In fact, this field was set up so that there was hills in one part of the field. It was hilled in one part of the field. Then there was a check strip where it was not hilled, and there was no cover on both of those. And then there was a part where it wasn't hilled, and there was a cover crop, but because the cover crop was put on so late, I think it was oats, it was put on so late that it barely grew, like it barely made a little green fuzz over the ground. And when I took yield samples from where there was cover versus where there wasn't, there was no difference in yield and no difference in soil quality. So kind of tells me that the cover crop just, barely started and didn't really have an impact. So we're comparing not hilled with hilled without a cover crop, and that's really what we're looking at. This was in central PEI, and there was a moisture deficit, but the yields were not too bad. They got a few timely rains here that kind of saved the crop. Not a bumper crop, but not too bad. And it was primarily a seed field, but it's a seed field. They also kind of take the top off for processing or table, but a lot of it would be grown for seed. So this is the bottom line here, the one in blue. This is the results from that field from last year. So about 20 hundredweight yield improvement on total yield, around that 18 mark on marketable yield, which is actually exactly the same as the trend over the number of years. In this case, we didn't see any difference on defects or smalls. Did see a bump in 10 ounce where they had made the hills, and a bump in gravity. And this amount of difference is probably bordering on statistically significant even in just that year. So haven't run the stats on it yet, but definitely a little more difference than we've seen in other fields in other years. again, we have this marketable yield and then a little bit more of a bump in payout because of the gravity in the 10 ounce. So that would make your payables a little bit, or your revenue per acre a little bit higher. So overall, it doesn't change our trend much this year. It kind of just supports that trend. So we're still looking at about 1,800 weight of an acre on marketable yield and about $200 and so dollars per acre, which is about the same as it was before. So what's the take-home messages out of this? I would say generally we're still numerically positive at 7 out of 8 or 6 out of 7 fields. And the trend over these is for a slight gain in hundredweight and a slight gain in payout per acre. At the very least, we can say that so far we don't see any trend on negative impact on yield. And if we add in the sort of the benefits of being able to get the ground tilled earlier, the opportunity to get a cover crop on, and shortening the amount of work that can be done in the spring, I think there's a dollar value to that as well that we're not capturing, in this type of analysis. One thing I'll note is the grower this year that did this trial with us, he took some soil moisture samples or tests in the hills versus the flat ground, and he found that prior to potato planting, the hills were about 2 to 3 degrees warmer. The soil was about 2 to 3 degrees warmer than the flat ground, and he said, well, that could have a big impact on emergence. In particular, he said he has some heavy ground, some wetter ground, that doing that hilling a bit earlier might help to dry that out a little bit more and reduce issues with fusarium or blackleg or anything down the road, soft rot, if he's planting into those hills. So this grower actually, he did 1 field last year, and this year he did about 75% of his acres with the hiller. He did leave check strips in several of them, so we'll have them for trials again next year. One thing I'll note, if someone was to go further down this road and do more of this on their own, maybe do more of their acres rather than just a field or two, other places that are doing this are making use of what we call a freshening tool with a sort of an S-tine on it. And so I have a picture of that. So this is one that I took a picture over in New Brunswick, and I think I've shown this before in a few meetings, but it's kind of like a finger weeder in a way, but it's sort of beating the top level of the hill. So you're not destroying the hill, you're leaving the hill intact, but you're just sort of freshening up the top inch or so of it, and that helps break up any clumps that might be there, break up some residue that's there. And then there's this sort of S-tine here that are on 30, in this case they're on 36-inch centers, and so that's going right down the middle of the row. So that's going down the middle of the row to decompact where the seed piece is going. And in Alberta, they published a study that showed that use of this freshener tool seemed to increase the tuber size profile a bit, so they had more 10 ounce and more payables. And a grower I talked to in New Brunswick, he's doing quite a bit of his acres on this as part of doing fumigation. The reason he's making the hills in the fall is to put chloropicrin in. But he said even if he didn't fumigate acres or decided not to fumigate in the future, he would still make the hills in the fall and use this freshener, because he said he sees quite a bit of benefit just from using this system, because he just goes ahead of the planter with this freshener, the day of, and then he can plant right into those hills. So it really cuts down on the amount of tillage he has to do in the spring. Any questions before I leave the fall hilling topic? I know I kind of went through that a little quick. We're on our 3rd year of trials on this, and we'll have 3 or 4 more fields this year that we'll be able to evaluate. And by that time, we should have some really good data to share. The trend is looking positive, and as I said, it's not just effect on yield, but it's effect on your total rotation and maybe your total operations, and whether that has some cost benefits as well. Any questions?
Ryan, is there any difference in erosion between fall hilling.
Yep. On the
Left,
fields,
left,
yeah.
yeah,
The
if you
fields,
left it
the
not
fields that we
planted.
sorry, I keep interrupting you. I'm sorry. The fields that we looked at, the first 2 years we picked primarily flatter fields. They weren't on they weren't on really rolling topography, and we didn't see any real evidence of any rill erosion or gully erosion or anything really noticeable. This year, the field was done. It was actually more of a hilly field, and there wasn't a cover crop on it, and we still didn't see much evidence of erosion. We didn't see like busted out hills or gully erosion down the furrows or anything like that. So so far, haven't seen any real evidence of bad erosion. Okay, if there's not any other questions, we'll just sort of move on. We got some take-home messages just to sort of sum up on where we were on a few of these projects. And then at the end, I have a couple of slides about biosecurity I want to talk about. So just kind of going back to the cover crop before potatoes trial that I talked about. What are the take-home messages? Early tillage and establishment has the most benefit. I think you're going to get the most benefit for the soil and the most benefit for potential yield improvement by doing it earlier and getting it established earlier, so you're going to maximize that biomass. If you're doing it, if you're seeding in August and early September, you've got greater crop choices. So you got the ability to do more, mixes. You could put brassicas in. You could look at putting in like winter peas, things like that. Some more frost tolerant legumes, that sort of thing. So you might, you have a little more options when it comes to crop choices. If you're doing it after September the 15th, generally what we've seen is I would stick with cereal crops. So I would stick with your barley or oats or something like that. The mixes can maximize coverage and the diversity of root systems. So again, we talked a little bit yesterday, like people, if they're planting a full stand of, say, tillage radish, then that breaks down in the spring. It breaks down pretty quick, and it releases a lot of nitrogen back into the soil really quick from those taproots. And depending on where you are and how that breaks down, it might release that nitrogen too early for the potato crop to take it up, and so you might actually lose a bit of that nitrogen again that you held over the winter. Whereas if you have a mix of tillage radish with, say, a grain crop like barley or oats or something, then it's not that same flush all at the same time, and you've balanced maybe your C to N ratio a little bit, and maybe you're not as at risk to lose all that nitrate. So there's some some benefits, I think, to some simple mixes there. The first year of data appears to show a yield benefit of using cover crops ahead of potatoes. So again, it's only 1 year, but there does seem to be a positive trend. If we say 2,500 weight an acre to be, that more conservative figure that we looked at, and we use processing contract, that's $275 an acre. The cost to put a cover crop on in the fall, a lot of the numbers I've seen is somewhere between $20 and $30 an acre. So we may be, we might be an 8 or 10 to 1, benefit just on yield there. Even if we have that benefit, you're still, your return is still very, very strong. So, and that's not taking into account, the cost of possibly doing one less tillage pass or not having to work ground in the spring and that sort of thing. So I think the total return of that system may be quite significant, as well as, of course, the environmental benefits of it. And I think the potential environmental benefits of it are quite strong. Morgan, you want to cover your section here?
Yes. Yes, so the take-home messages for the cover cropping after potatoes, we can say that the cover crops were good at holding the soil and good at catching snow over the winter months. They're also good for improving soil health, even if they're getting established later. And based on the results of the trials that we've been doing so far, we would recommend using winter cereals such as fall rye or winter wheat because they've had good methods and good rates of establishment. Although we would not recommend spring cereals like barley and oats necessarily, especially if they're seeded after October 5th, because we find they didn't grow enough, especially in the cooler soil temperatures. And even if we only have a little bit of establishment, a little bit of green growth, it's definitely better than a check strip that has nothing. And if you have some green growth, it'll give you more than what you would have without anything. So we say double that much root growth than what we would have otherwise. It's all for holding soil.
And and then sort of just revisiting the fall hilling. Again, 3 years of research appears to show a positive trend for yield and quality with regards to fall hilling. But the total system approach allows for earlier land prep, maximizing cover crop use, and reducing tillage, which all of this has both a financial and a soil health value. So I think beyond just the effect on yield, even if there was no effect on yield, like even if we did it again this year and we saw no impact on yield, I think there's value in the operational side of this that might be worth considering for people. What I would say, if someone was planning to do this on a bit of a larger scale, like if you just want to try out a field or two, that's one thing. But if you're going to do it on a little larger scale, I would consider maybe looking at getting one of those sort of freshener tools, and that might help avoid lumps, reduce that surface crusting on the top of the soil, and allow you to just go in and plant right into those hills after that little bit of a freshener. And they are doing this in other areas. So New Brunswick, Ontario, Alberta, I've talked to growers in all those areas that are doing this hilling, and they seem to be very happy with it in terms of getting that land prepared a little earlier. Particularly Alberta, they like it because, they try and plant in April in Alberta. And so this allows them to get going as early as possible because they know they don't have the luxury of a longer season in October like we do. So they're trying to get it in early and get it up early. So any questions on any of those three, sort of topics before we sort of conclude with our thoughts on a few slides on biosecurity? I know we're getting on in time, or we'll be done in about 5 or 10 minutes, but just any further questions or comments or stuff you'd like to see us do different? All right, hearing none, we'll keep rolling. So just a few additional resources. This presentation will be up on the agronomy website in the next couple of days. So you'll be able to, you can click these links yourself in the future. But OMAFRA's got a couple of really good documents that I would recommend you can look at. So they have just a basic use of cover crops page, which is quite useful. They also have a specific fact sheet around best management practices for winter cover crops. And I already used a table from this, but it's a very good document, and I'll make this available. I'll link this on the agronomy site as well. Of course, SARE in the United States is a very good resource for all things soil health and cover crops and that sort of thing. So they have a good page on cover crops. I've mentioned this one quite a few times in the past, this cover crop decision tool. So this was developed, I think originally in the Midwest, and then it was amended or it was adapted for Atlantic Canada and Eastern Canada. And so you can go to this and go you can go province by province and even select your county. And in that, it'll give you an establishment window for different crops. Actually, if I click it now, maybe it'll bring us to, yeah. So in this, here's your cover crop tool. We can select Prince Edward Island. We select vegetable for potatoes. I can say Queens County, and it'll give us a reliable establishment window for different crops. So, pearl millet, it says don't plant it until for consistent emergence, don't plant it till the 23rd of June. Don't plant it after the 19th of August, those sorts of things. Here's your oats and barley. So here they're saying reliable establishment till the 26th of September, might establish till the 15th of October, whereas, your winter rye, reliable establishment to the 15th of October, might establish to the end of October. So that kind of gives you a little bit more of an idea of your different things you could use. Even includes things like frost seeding for like ryegrass and timothy. You've got your legumes, you've got even some mixes in here. So I find this a very valuable website. And then you can click on these individual crops and it'll bring you into an actual, it's got recommended seeding rates and seeding depths and, what it's good for, what it's not good for, pros and cons, cultural traits. So this is a very valuable website. So I would recommend using that if you're looking a little more to figure out what's the right cover crop for you. And then a couple years ago, I did up a fact sheet that's on the agronomy site now, which also cites this decision tool, but just gives a little bit more of in-depth on some of the topics we covered today. So just a little bit on biosecurity. So with the recent cases of potato wart and BRR that many of you will be familiar with over the last, it's kind of been in the news or that we've informed you about in the last little while, it's more important than ever for growers to pay extra attention to biosecurity. So we should always be thinking about biosecurity, but even more so now. What does this include? What does this encompass? This includes all movement of potatoes onto your farm. So if it's, if you're buying seed, where does your seed come from? What are the biosecurity measures that your seed supplier is taking? Is there any other crops coming onto your farm that you need to, be concerned about, cleanliness and disinfection? Movement of equipment onto your farm. So are you renting a tractor from John Deere, or are you renting a piece of equipment, or are you trialing a piece of equipment, or are you borrowing a piece of equipment from the neighbor? Any of these things, that equipment needs to be disinfected and cleaned before it goes into your field. Same with if you purchase a piece of equipment, particularly if it's coming from a potato farm, that needs to be, very thoroughly cleaned and disinfected. Access to fields by people from outside your farm. That includes Morgan and me. Includes anybody doing soil sampling or crop scouting or anything on your fields. They should be, if they're going into your fields and not just, on your, the side of the headland or something like that, and they're going into where there's, they're making soil contact, they should be cleaning and disinfecting their shoes, any of their tools, try and not take vehicles in the field or stick to roadways, that sort of thing, but not going into fields. Whenever Morgan and I go to any of your fields for trial purposes, we're spraying our feet before we go in and out. We're spraying and cleaning any of our tools to make sure we're not tracking any bugs from field to field. And then, of course, cleaning and disinfection of all storages and equipment. That's really important, especially for things like BRR. Not having it carry over from year to year is incredibly important. So many of you have already received this document in paper form, which is the CFIA Biosecurity Standards document. If you don't have it, this is the link for it. Again, this will be posted on the agronomy website and you'll be able to link through to it. But also, I believe this link was also emailed out to all growers in the last couple of weeks as well. So if you don't have a copy of it, you should probably go and get a copy of it. And finally, we also sent this out by email, but a few years ago, back when we closed the disinfection site in Borden, one of the things we did was invest in doing some videos on biosecurity for on-farm biosecurity and cleaning and disinfection. So there's a playlist of 4 different videos that you can go and view. There's one on plant biosecurity itself and why that's important. Disinfection for BRR and other bacterial diseases. And this is big, not just for BRR, but a big one in the last few years in some varieties is blackleg. And we seen a little more aggressive blackleg that seems to be surviving later in the season. So what can you do to prevent the spread of blackleg? Cleaning and disinfection of equipment, and then cleaning and disinfection records and possibly funding available if you need to invest in, cleaning equipment or anything like that, or training. So there's a playlist here. You can go watch those. The videos are primarily done by Dave McSwain, who works with us at the board on a bunch of different projects, as well as Sulky DeBoer, previously of CFIA. So with that, that kind of takes us to the end of our presentation. Is there any other additional questions before we wrap this up, or comments, or things that you want us to look at?